Okay. What is your question from last time?
Okay, so it was I forget which, it might have been like question 8 or something from the 8 point or the 1.2 homework, but it was open
But the question
parentheses.
differs from students.
1.2, right? Homework.
Yep.
We'll define. What's the question?
It was open parentheses.
Open parentheses.
8
square
root of a.
Square root of a.
Yep.
Like 8 times
No.
x.
No. So
Yeah.
8 times a to the power of 1 over 2. 8 times the square root of a.
8 times square root of a.
Yeah. And
Like
parentheses.
Parentheses.
Times parentheses a. Yep. To the to the fourth power.
To the fourth power.
Under root under the third root. Excuse me. So it's
under the 4 over 3, right?
Yeah. Thank you.
Like this, right?
Yeah.
Okay. So let me write it again. So open parentheses, 8 times the square root of a times a to the 4 over 3. How we can solve something like that? Okay. Who have idea? How can I solve something like that?
Rewriting the square root of a into exponential form.
Exactly. So he said this thing, see this thing, the square root of a, I can write it as a rational expression, rational exponent. So this is equal 8 times a to the power 1 half, right? Because I said radical, the square root of a is the same, or I said like last time, a to the m over n is exactly like the root, the nth root of a to the m. Here actually we have 2, and the power of a is 1. So this will be 1 over 2 times a to the power 4 over 3. So we have the same base, a and a, different exponent. What does that equal? The number goes out times a, because we have the same base, different exponent, we do summation for the exponent for the same base. So this is equal 8 times a to the power 1 half plus 4 over 3. Now we learned these things in last class, in previous classes. This, how to add fraction. It's 11 over 6. Or let me explain more. 1 over 2 plus 4 over 3. This is, we do cross multiply. 4 times 1, 3 times 1, 4 times 2, 3 times 1 plus 4 times 2 is a over 2 times 3. A to the power 11 over 6. Or this, I can express it in the question over maximum who asked this question? Who asked this question?
I asked it originally, Will Davis. You're lagging pretty hard, Professor.
My audio. Now clear. But after,
Yes, a little better.
okay. So now let's go to the 1.4 rational expression. So last time I started briefly for this thing, but we did not continue this class. So what is the meaning of rational expression? So rational expression is a quotient of what? Quotient of two polynomials. I mean, for this, like rational expression looks like fraction polynomial over polynomial.
So
Okay.
that's also known as long division, right?
Yeah, polynomial over polynomial, division of polynomial over polynomial. It's not, we're not going to learn how the long division. We have to know what's the meaning of rational expression in general. So what's the meaning of polynomial? Polynomial. Last time I talked about polynomial. What is that? So polynomial in general, give you a brief definition of polynomial. It's an expression. Exactly, Angel. Expression look like of the form, like something like an x to the n plus an minus 1 x to the n minus 1 plus dot 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 plus a1x plus a0. Such that an and to the a0, all of them real. This is the real number, real number, real number, real number. Such that this guy and this guy and this one and this one real numbers. And the n here, you see the n, it's natural number. Or 0. Makes sense? So anything of this form, it's a polynomial. an minus 1, y1, 0, all of them real numbers. The n, it is a natural number or 0. Any question for the polynomial and rational expression? Which of these are rational expression and which of them not rational expression? For example, which of this is rational expression? First one, 2x over x minus 1. Second, square root of x over x squared plus 1. 3, x to the power 1/2 over 5. 4, 2x over x minus 1. The first one is the rational expression. This is the rational expression. The first one is rational expression. Can you turn on the mic, please? Zisham.
As long as x is greater than 1, I believe it should be.
Okay, perfect. But no, this is good. Like this is an answer, but what is the like? How you can think this is expression or not? Is a rational expression. So I said before, rational expression must be look like polynomial over polynomial. Polynomial over polynomial. This is polynomial 2x. Is it a polynomial? Yes, it's polynomial. What is the second one here? The denominator. It's a polynomial x minus 1.
Yes.
Yes, a polynomial. So this is a rational expression because 2x and x minus 1 are both of them polynomials. And x minus 1 polynomial. This one, second one, is a rational
No.
expression?
No, it's not.
No. Why it's not rational? Can you explain more?
Because the exponent in the numerator, the exponent of x is 1/2, which is not a natural number.
The exponent for the numerator, it's 1/2. It's not natural number. Nice. So this is actually look like x to the power 1/2 over x squared plus 1. X to the 1/2, 1/2, it's not natural number. 1/2 here. This guy. It is not natural. So this is mean x to the 1/2, it's not a polynomial. So x to the 1/2, not polynomial. I said to be polynomial must be natural number or 0. Not a polynomial. So this is mean, so not rational expression. Okay. For number 3, who will solve number 3? Who will do number 3? Who will do number 3? Here. Number 3, who will do it?
I can do it. I don't think it's a polynomial.
It is not. That's true. The answer is no. Why?
Because x1/2 is basically the same thing as the square root of x.
Exactly. So number 3, it's look like number 2. Here, x to the half. This is x 1/2 over 5. It's exactly 1/5 times x to the half. And 1/2, it's not natural number. 1/2 is not a natural number. This guy is not belong to natural. One over two not belong to natural number. For the fourth one, who will do the fourth one? This one. Who will do the number 4?
I would say that it is a polynomial.
Yes, the numerator is polynomial. The denominator is polynomial, right?
Yes.
Look, no fraction and the exponent. The exponent is not a fraction. So the exponent for x is 1, no fraction. The exponent for x here again 1. The exponent for x equals 2. This is polynomial. 5x is polynomial. X minus x squared is polynomial. So here, yes, it is rational expression. It's 5x and x. Yes, that's true. Advent. This is right. Any question so far? So now let's go to the new topic, the domain. I talked briefly last time about the domain. I will explain more for this class. The domain of an algebraic expression. So what's the domain? Like I said last time, domain is a set. It is a set of real numbers. So a set of real numbers, which this number, which will make the expression define. If these numbers make the expression define, the set of these numbers, that's mean called the domain. I give you last time example too. Give last time example. Okay. Example. So I have expression. And here are the domain. First one is 1 over x. Second one is the x squared. Third one is 1 over x squared. 1 over x. So what's the domain for 1 over x? I mean, what is the numbers can I plug it inside this expression and make the expression define? So you ask yourself, if I plug positive numbers 1, 2, 3, 4, it will keep the expression well defined. If I plug negative 1 over minus 2, 1 over minus number, keeps the expression well defined. But if I plug the 0, let's make the expression 1 over 0, let's make the expression undefined. So like Angel, he said, all real numbers except the 0. Or if I want to explain this, x such that it's not equal 0. This is mean all real numbers except the number 0. For the second one, who will do the second one? For the second one, I said, if I have radical such that the exponent, the root is even number. So this one is even, look, square root. The 2 is even number. 2, 4, 6, 8, all of these even number. Okay. If the root of the even number inside the radical must be positive or 0. So I said last time, the domain will be x, all the positive number and the 0. That means it looks like x such that x is greater than or equal 0. This means all the positive real numbers and the 0 itself. For the third one, who will do the third one? So all positive real numbers and 0. Who will do the third one? Angel, you want to do the third one? Who will do the third one?
I think it's all real numbers except 0, right?
For the third one, it's not right, but I will explain why, okay? For the third one, let me go to the next slide. It is, he said all the positive numbers, 1 over square root of x. So 1 over x. So if I plug the positive inside this expression will be defined? Yes, if I plug 1 over 2, 3, 4, positive is good. If I plug negative, I said from the third one, I can plug negative. Why? Because even number here. So I can plug negative. But what about if I plug 0? If I plug 0 inside this expression here and inside the radical will be defined, but for all the expression will be defined, the 0? No, why? Because 1 over 0, it's undefined. So the answer, it's look like the second one, but except the 0. It's look like this one here, except that x greater than 0 only, without the equal. Why without? Because if I plug the 0 here, that make the expression 1 over 0 undefined. So the answer here, x such that x is greater than 0 without the 0, because if I plug the 0, keeps the expression undefined. Make sense?
Yeah.
Let me give you examples more, but this example is for polynomial. Is not for I mean like not for algebraic expression, for rational expression. Like I said, rational expression is polynomial over polynomial. This is not polynomial here in the denominator. Okay, let me give you what's the domain. Find the domain for number 1, 2, x to the power 3 plus 4x plus 2. What's the domain for this one? Who will answer this one?
So you mean the domain?
How-
We first need to factor by 2. Simply on the numerator we factor by 2, there will be s to the cube plus 4 plus 2 plus 1. Then we again factor, and then we set equal those values equal to 0.
Okay, but this is not equal. Is not. I mean, here we don't need to factor. The question is find the domain. I mean, like, what element you think like that? What element can I plug it inside this expression? What numbers can I plug inside this expression?
All real numbers.
All the numbers. That means all real numbers. If I plug 0, will be good. If I plug 1, 2, 3, 4, will be fine. Will give me define. If I plug in the negatives, also would be defined. So that's mean, like Angel, he said, the domain is the real numbers. So that's mean if I plug negative numbers, 0, positive, keep me defined. Make sense? Second one, x over x squared minus 5x plus 6. What is the domain? Again, the domain, what elements can I bracket inside this expression and keep this expression well defined? Make sense? If I plug the 0 in the denominator, first things I have to think like separately, denominator and numerator. For the numerator here in the above, for x, I can plug positive numbers. Yes. I can plug negative numbers. Yes. Can I plug 0? Yes. Why? 0 0 over this give me 0. So we'll define. For the second one, for the denominator down, I can divide something over 0. So this is mean I need to remove the 0 from this expression. I need to remove the 0 from the denominator. So how can I remove the 0? I need to factor this one. So this is equal after I factor it. What's the factor for this one? What's the factor from last time? What's the factor for this one? X squared minus 5x. I need two numbers. If I multiply, they give me 6. And the sum of these two numbers, they give me minus 5.
Negative
Exactly.
1.
What is that? Two numbers. If I multiply for together, they give me 6. And the sum of these two numbers, negative 5.
Negative 6 and 1.
Negative 6 and 1. So negative 6 and negative 1, right? Because negative 6 times negative 1
Oh, shit.
is they give me 6. And the sum of them, they give me minus 7. So not, this is not the factor. Martin, he said x minus 3, x minus 2. Let me check the minus 3 and the minus 2. Minus 3 times minus 2, give me 6. Good. And the sum of these two numbers, they give me minus 5. Perfect. So the answer is x. So the factor is x minus 3 and x minus 2. Okay. So now we're thinking in a different way. I'm thinking, how can I remove the zeros from the denominator? So if I plug 3 inside the denominator, they give me 0. So I have to remove it. If I plug 2, they give me 0 in the denominator. So I have to remove it. So this is mean I can plug any numbers, all real numbers, except the 0 of the denominator. And what's the 0 for the denominator? It's 3, because if I plug the number 3, they give me 0. And number 2, if I plug 2, they give me 0, except 3 and except 2. Okay? Because if I plug 3 minus 3, they give me 0. And 0 times this expression, they give me 0. So in other words, I can write it as x such that x not equal 3 and x not equal 2. Make sense? Any questions so far? Anyone has a question? Okay. So now let's go to simplifying rational expression. How we can simplifying a rational expression. Simplifying. Rational expression. So how can I simplify rational expression? So I'm using two ideas. First idea is called to factor for the numerator and denominator. Then I use this property. So I have to factor both of numerator and denominator. Okay. Second thing, we use this property. Property says A C over B C. I can like cancel C with C, and this is gonna give me A over B. I give example. For example, x square, simplify this expression, x square over minus 1 over x square plus x minus 2. Okay, what's the factor for the numerator? So first things, we factor the numerator, we factor the denominator, we cancel wherever are possible to cancel. What's the factor for the numerator?
X minus 1 and x times x plus 1.
X minus 1 times x plus 1. Yes, that's true. He used the property from the last class. It says, if I have something like that, like if you go back to the property from the last class, you will see it in the note. So I'm not going to lose the time for this one, okay? For the second one, what is the factor for the denominator? This is three geometry. This is three polynomial. Trinomial.
X plus 2 and x minus 1.
X minus
Plus 2.
2.
Plus 2.
And
x minus 1.
Exactly. Why? He's thinking like that. Which two numbers, if I multiply, they give me minus 2. And the sum of these two numbers, they give me 1. So minus 2 and 1, and I mean positive 2 and minus 1, the multiplication of these two numbers, they give me minus 2. And the sum of these two numbers is they give me 1. So 2 minus 1, they give me 1. And 2 times minus 1, they give me minus 2. So they are x plus 2 and x minus 1. Now, what I can cancel? What's the similar of the numerator and denominator? I can cancel it.
X minus 1.
X minus 1 with x minus 1. What's the answer? X plus 1 over x plus 2. Make sense? Any questions so far? Give you another example. example 2. Okay, x minus 2 over x squared minus 4. What does that equal? How can I simplify it? How can I simplify this one? The numerator is simple. X minus 2, it's simple. Is it simple? Yeah, we can factor the numerator more than this. Can we factor the numerator more than this?
No.
We cannot.
No.
So we keep it the same things. The denominator, we can factor it.
Yeah, x plus 2, x minus 2.
X plus 2 times x minus 2. What we can cancel?
X
From
minus 2.
numerator and x
1.
minus 2 with x minus 2, right?
1 over s
What
plus
does that
2.
give me? 1 over, this is equal 1 over x plus 2. Any question? Okay. So now let's go to multiplying and dividing rational expression. How we can multiply and how we can divide rational expression. Okay, so again, the idea for this one, we factor the numerator and the denominator, then we use this property. So we have two things, we factor as we can, then we use this property over B times C over D fraction. This is equal A times C over D times D. Make sense? Any questions so far? So now I'll give you an example. How we can multiplying this fraction x squared minus 25 over x squared minus 9 times x plus 3 over x plus 5. First things I said we factor as we can. Who will do it?
First, we factor the different square. That will be x minus 5 times s plus 5.
Yes.
Also, the denominator, we do the same thing, will be s plus 3 times s minus 3. We cancel that
Good.
plus 3, both sides, the denominator and the numerator. Same with the s plus 5.
Perfect. So again, we factor. What's the factor? Like you said, x minus 5 times x plus 5. This is over x minus 3, like he said, times x plus c multiplying by x plus 3, x plus 5. So we can simplify, then we do the property. Which one I can cancel it? I can cancel this one with this one, right? I can cancel this one also with this one. So what I get here, so they give me only this one, x minus 5 times 1, because the remainder is 1 here. Here the remainder is 1. So it will be like x minus 5 times 1 over x minus 3 times 1. And anything times 1 is will give the same thing. So the answer is x minus 5 over x minus 3. Any question? Anyone has a question? No one has a question. Example number 2. If I have something like that, let me go to the next slide because the question is more bigger than this one. So next slide. The question is x to the power 2 x squared plus 2x minus 3 over x squared plus 8x plus 16 times another fraction 3x plus 12 x minus 1. What? Here I have a question. Why did you times by 1? Because when I simplify this guy, they give me 1 over 1. This removed, numerator is cancelled, the denominator is cancelled. So I actually multiplying this guy. It's become look like exactly like x minus 5 times x minus 3 times 1 over 1. Okay. And this guy times 1, I make it one fraction like this property. Look, this property. Fraction times fraction. It looks like x minus 5 times 1 over x minus 3 times 1. And the one I said like something was multiplied by 1, this times 1, they give me the same like this one. And this is equal x minus 5 over x minus 3. Okay. Makes sense? Okay, let's go to the next class, next section, next slide. Here, how can I simplify? How can I factor the numerator? What's the factor for the numerator and the denominator here? From last class, what's the factor?
S plus 3 times x
X
minus 1.
Okay, x minus 3 or plus
1
plus
minus 1.
and x minus 1. for the denominator of the fraction.
S times plus 4 times S plus 4.
Exactly. Times, how can I factor this one? What's the common factor between first term and second term? It is 3, exactly. What's the greatest common factor between this term and this thing? Just only 3. What's the rest? Plus 4. This is just review from last time. If you go back to the last class, you will see the review for this one. Down is 6x minus 1. Exactly, Chris. Now, how we can simplify? Which one I can cancel with the other? Here. Which one I can cancel it?
S minus 1 and S plus 4.
This one with this one, plus 4 with x plus 4, right? Here the remaining is 1. Here is 1. So now, what does that equal? X plus
3
3
times S plus 3 over
times
4 plus
1
4 over S plus 4.
over x plus 4 times 1, exactly, like he said.
You're missing a
And this
3.
is equal x plus 3 over what? X plus 4.
You are missing a 3.
You're missing a 3.
Oh, 3. Yeah, I'm sorry. So it's 3 times 1. So everything times 3. So again, here not 1. So this is here 3 times 1. Give me 3. Here down, it's like 3 times this one, 3 times x plus 3. And this gives me 3x plus what? 9 over x plus 4. Why? I distribute. Okay? Any questions so far? That's it. Okay. Now, how we can dividing Russian expression? Before I go to divide, it makes sense. Is it clear here how you do it? How you multiply it to fraction? Okay. So divide rational expression. So the property said A over B divided by C over D. This is exactly the first fraction multiply the flip of the second fraction, D over C. The first fraction times the flip of the second fraction. Let me give you an example.
Reciprocal.
The reciprocal, exactly. So let me give you an example. X minus 4 over x squared minus 4 divided by x squared minus 3x minus 4 over x squared plus 5x plus 6. So again, by using the property A over B, this is my A, this is my A, this is my B, this is C, this is D, this is A, B, C, D. So A is x minus 4 over B, x squared minus 4 times the reciprocal for this one, D over C, x squared plus 5x plus 6 over what? X squared minus 3x minus 4. Make sense? Now, as we learn in multiplication, in this part and above, we're doing here the same exactly. So first things, like before, we factor as we can, then we multiply. Here, how we can factor this guy, and this one, and this one, and this one. What's the factor of x minus 4? What is the factor for x minus 4? It's factored already. No factor for this one. It's factored already. What's the factor for this one?
X minus 2, x plus 2.
X minus 2 times x plus 2 times. What's the factor for this one?
X plus 5.
Plus 5. I need
No, hold
two
on, sorry.
numbers.
Oh, yeah, x plus 3, x plus 2.
Exactly, 3 and 2. X plus 3 and x plus 2, because 3 times 2 is 6, and the sum of 3 and 2 is 5, the second one. For this one, what's the factor?
X minus 4, x plus 1.
X minus 4 times x minus 1. Why? Because minus 4
Plus
times
1.
plus 1. Minus 4 times 1 is minus 4, and the summation minus 4 plus 1 is minus 3. Now, what we can cancel? We can cancel x minus 2, x plus 2, right? This one with this one.
X minus 4.
And what else?
X minus 4.
X minus 4 with this guy. Exactly. What else we can cancel? Nothing. That's it. So what does that give me? They give me x plus 3 over this guy times this one. X minus 2 times x plus 1. Any question? Makes sense for all of you? How we think to do this question? Okay, so let's now go to the adding and subtracting rational expressions. How we can add and subtract rational expressions. So we learn how to multiply. We learn how to divide. Now we're going to learn how we add and subtract. So adding and subtracting rational expression. So how is the idea here? The idea here to find the common denominator. I mean, like I need the denominator are equal, similar to each other. And by using section 1.2, finding the least common denominator here. We're going to find the least common denominator. Second thing, we have to use this property or A over C. After we find the common denominator, we use this property A over C plus B over C. Give me A plus B over C because the denominator are equal. Makes sense? Here we can find it by the least common denominator from section 1.2. Let me give you an example. So the example is 3 over x minus 1 plus x over x plus 2. How we can solve something like that?
Cross multiply.
Okay, we can do the cross multiply, or we can using the least common denominator using this idea. So you take it, so you're going to look into the first fraction, you take the denominator for the first question, and you ask yourself the factor. You factor the denominator for the here and the factor the denominator for the second fraction. So the factor of x minus 1 is, what's the factor for this one? What's the factor for this one? For this denominator here. Is factored already. We cannot factor it more, so it keep it like this, x minus 1. What's the factor for the second factor for the second denominator?
Same, we cannot
The
factor.
factor of x plus 2 is factored already, so is x plus 2. You ask
So the
yourself,
LCD will be as minus 1 times as plus 2.
yeah, so there is nothing to cancel like we learned in section 1.2. So you multiply this fraction by this factor, x plus 2, and you multiply here again the numerator and the denominator by x plus 2. What you multiply here? This one, you multiply by this guy, x minus 1. X minus 1, x minus 1. So what's the answer? So the answer is 3 times x plus 2 over x minus 1 times x plus 2 plus this guy x times x minus 1, here x minus 2 times x minus 1. So look to the denominator. This one and this one are equal. Sorry, here plus x plus 2, x plus 2, x minus 1, x minus 1. So the denominator and the denominator are equal. So now we can combine the denominator. So this is equal here. Going down. One denominator, x minus 1 times x plus 2. Now we multiply 3 inside the fraction, this expression inside the parentheses. 3x plus 6. We distribute it. plus x times x is x squared minus, because x times minus 1 is minus x. So what's the solution for this one? What is the answer here? What's the answer? Here, look,
X squared plus 6 plus 2x.
x
Or
squared
x squared plus 2x plus 6, sorry.
plus 2x
Plus 6.
plus 6. Here we do like we learned last time, it's a polynomial. We're looking for combined like terms. Okay, so x squared is alone. We have minus x plus 3x. So x and x, the same variable, raised to the same power is 1. So we combined the 3x with the minus x. They give me 2x because 3 minus 1 is 2. And the number 6, keep it alone, plus 6. Any questions so far? Makes sense? That's it. Angel, he said no, but what about the other student? Any question?
No, that makes sense.
No, okay. Disham,
Yes.
makes sense for you?
Yeah, it makes sense. I understand it.
Okay. So now let's go to the something a new topic. It's called compound factor. No, let's okay. So we did this example. Let's do another example. Or I will do the other example in the last of the class. Let me go to the compound factor. If we have time. Compound factor. What does that mean? This is mean if I have fraction such that the denominator of this fraction has a fraction and the numerator has a fraction. I mean like fraction over fraction. Yes, we have a quiz in the last of the class, the last time on the class, the last 15 minutes of the class. Okay, I give you example, what does that mean? And we need to simplify. The question is simplifying something like that. X over y plus 1 over 1 minus y over x. Look, fraction over fraction over fraction. I need to simplify all this compound factor. So how we can think about this question? To think about this question or to solve a question like that, we have to write it separately, the denominator and numerator separately like this. This is equal x over y plus 1 divided by 1 minus 1 over x. Okay? This is equal exactly like that. X over y plus 1 divided by 1 minus y over x. Now we simplify this one. Then we simplify this one. Then we divide both of them and you get one fraction only. So how you simplify this one? I need to simplify this one. This is actually over 1. So you do cross multiply, right? How you do it? Who will help? This is over 1 actually. How you do with this one? How you going?
You want to cross multiply x over y with 1 over 1?
Yes.
Wouldn't that just be x over y?
So what's that equal? How you do it cross multiply? You know how? This is equal to x over y plus 1 over 1 actually.
Mhm.
So what are you doing here? So you multiply x by 1, y by 1, and y by 1. So it will be like x times 1 plus y times 1 over y times 1. So they give me x times 1 is x, y times 1 is y over y. So this is the first one here. Second one, 1 minus y over x. Same idea exactly like the first one. But I like to put the minus to the y and keep it positive. This is equal 1 plus minus y over x. Okay? Now exactly like before up here. This is actually over 1. We do a cross multiply. 1 times x plus minus y times 1 minus y times 1 over x times 1. What does that give me? X, because 1 times x is x, minus y times y is minus y over x. Now we're dividing this guy by this one. So the third thing, x plus y over y divided by x minus y over x. So how you do with this one? We change the division to multiplying like before, and we do the reciprocal for this, or we flip this guy. So this is equal x plus y over y times x over x minus y. Anything we can simplify, cancel? No, we can't cancel anything. So what's the answer? X plus y times x over y times x minus y. Any question? So this is number 1 here. This is number 2. Here number 1, number 2. Then we divide everything. Make sense? Easy? So we have like 1 minute before we go to the quiz. So avoiding common problem. Common errors. We have some common errors. Most of the students, they get wrong for this one. So the first common error is that A times B, all of this to 2 is equal A squared times B squared. But this is not work for addition, but A plus B square, what is that equal? Is it equal A square plus B square? Is this equal? No, this is not equal. This is equal A plus B square is equal actually A square plus 2AB plus B square. Okay, this is the right thing. Second one, square root of A times B, this is equal square root of A times square root of B. This is work for addition. Does it work for addition? Can you say it like square root of A plus B is equal square root of A like plus square root of B? This is true. This is true. This is not true. Square root of A plus B is not equal square root of A plus square root of B. Okay. Number 3, A square times B square is equal A times B. But for addition is not true. A square plus B square is not equal. Give me one angle. I need like 3 minutes. I will start the quiz. Square root of A square plus square root of B. This is not true. This is wrong. Okay, so make sure you understand this 3 things. The last one, AB over A is equal B. I can cancel A with A. But this is not true for addition. A plus B over A not equal to B. Okay? But it's not equal. Any question? Okay, so everyone, right now, open the web assignment. Let me stop recording for this class.